In this video, we're going to discuss the formula for binomial probabilities and how to solve for binomial probabilities. So the formula for binomial probabilities is P of x is equal to n choose x times the probability of x, let me back up. It's times P raised to the x power times 1 minus p raised to the n minus x power. So what this is it's the combination of your number of trials, choose the number of successes that you want, times the probability of successes raised to however many successes you want, times the probability of a failure raised to basically the number of failures that you're looking at, because it's the total number of trials minus the successes, which would leave you with the number of failures that you're talking about. And so let's look at an example of how to do this. So let's look at on-time flights. So according to flightstats.com, American Airlines flights from Dallas to Chicago are on time 80% of the time. Suppose 15 flights are randomly selected and the number of on-time flights is recorded. So when you're looking at this, this is a binomial because either they're on time or they're not on time. And so a success is if they're on time. Okay? And the probability of that happening is 0.08. Or I'm sorry, 0.8. So the probability of them not being on time, 1 minus p, is going to be 0.2 or 20% of the time. Now, the number of trials that we're looking at is 15. So n is equal to 15. So we have our p, we have our 1 minus p, and we have our n. So let's look at part A. Find the probability that exactly 10 flights are on time. So for this one, we're wanting just the probability that x is equal to 10. So that means that we're going to do 15 flights, and we're going to choose 10 of them to be on time, times the probability of them being on time, which is 0.8, raised to the 10th power, because that's how many on-time flights we want, times the probability of them not being on time, which is 0.2, raised to the 15 minus 10, which, if you think about it, if there's 10 flights on time out of the 15, how many flights are not going to be on time? And the number of flights that are not on time is going to be 5, which is our 15 minus 10. Now, if you recall, this combination of 15 choose 10 is the same thing as 15 factorial over 10 factorial times 15 minus 10 factorial times our 0.8 raised to the 10th times 0.2 raised to the 5th. You can do this out by hand, or you can use your calculator using the PRB button. If you use 15 PRB and scroll over until you see the NCR and then do 10, this right here will give you the number that replaces this, which is 3003 times 0.8 to the 10th power times 0.2 to the 5th power, and we multiply that out and we get 0.1032. So the probability that exactly 10 flights are on time out of the 15 that we chose is 0.1032, or about 10% of the time. Now let's look at I want at least 10 flights to be on time. So if I'm looking at the probability for at least 10 means greater than or equal to 10, because I want at least 10. So that's looking at the probability of 10 plus the probability of 11 plus the probability of 12 plus the probability of 13 plus the probability of 14 plus the probability of 15 flights being on time. So I actually have to do this calculation right here for each one of these. So I'm going to do probability of 10 is equal to 15 choose 10 times 0.8 to the 10th power times 0.2 to the 5th power. Notice that my exponents are equivalent to my total number of trials. Probability of 11 is equal to 15. I'm going to select 11 of them to be on time, times 0.8 to the 11th, times 0.2. Now, if 11 of them are on time, that means that only 4 of them are not on time. Plus, now I'm going to do probability of 12. Oh, that should be 15. Choose 12 times 0.8 to the 12th, because 12 of them are going to be on time. Now, if 12 are on time, that means that only 3 are not on time. Then I have 13, 0.8 to the 13th, 0.2. If 13 are on time, only 2 are not on time. So then I have 14. So 14 are going to be on time, which if 14 are on time out of 15, that leaves only 1 that is not on time. And then I want 15 that are on time. And so if I want all 15 of them to be on time, that leaves me with 0 that are not on time. And I'm going to get a value for each one of these. And getting that value for each one is going to be 0.1032, 0.1876, 0.2501, 0.2309, 0.1319, and 0.0352. And then I'm going to add those up. When I add those up, it's going to be 0.9389. Okay? And so the probability that at least 10 are on time is 0.9389. Now then, part C wants to know the probability that between 8 and 10 flights, inclusive, meaning that we include the 8 and 10, are on time. So that's referring to the probability that it is between 8 and 10. So that's going to be the probability of 8 plus the probability of 9 plus the probability of 10. So I need to do the probability of 8, which is 15, choose 8, times 0.8 to the 8th power, times 0.2. If I want 8 of them to be on time out of 15, that leaves me with 7 that are not on time. The probability of 9 being on time, 15 choose 9, times 0.8, raised to the 9th power. And if 9 are on time, that's going to leave me with 6 that are not on time. And then 10, 15 choose 10, times 0.8 to the 10th power. And if 10 are on time, that's going to leave me with 5 that are not on time. Calculate these, using either by hand or with your calculator for the combinations. That's going to give me 0.0138, 0.0430, and 0.1032. Then I will add those up, and I will get 0.16. So the probability that it's between 8 and 10 flights that are on time is 0.16. So try some binomial probabilities by hand using the formula, and remember that the exponents have to add up to your total number of trials. This first one, however many you choose, is the number of successes that you want. So you want to make sure that that is on your success probability. And if you have questions, let me know, and I'll be glad to answer them.